Okay. So, yep, okay. I don't know why it tells me that because I don't know what to do about that, but. Okay, so we are in chapter 2, section 2.1. We'll get most of this done today, probably not all of it though. But first thing first, I see a new vocab word. I see the word polynomial. What does a polynomial function mean to you? What should it have in it? So many pieces. Yeah, Sophia, you want to add to that?
Like, isn't if there's like an x, it has to be like to the, it should be squared or greater. I can't think of the right words, but
Good. We'll have variables and we'll have exponents. I'll have to look and see if lines count as polynomial functions or not. I am in my head thinking like linear counts as polynomial, quadratic counts as polynomial. Basically, your exponent just must be a positive number. If it's a negative number, that makes it a fraction. If it's a fraction exponent, then that makes it a radical. And so those are two different types of equations. Okay, so I'm looking at this next section. I've got A through E, and I want to know, is it a polynomial or not? And if it's not, what function is it? So for letter A, is that a polynomial function? No, why not, Ava?
The 15 powers.
Good. Do we know what function that would be? Andrew? A fraction. What do we call those? You're asking a lot, Miss White, on the last day of the week, Ryan? Not radical. The other R word. Reciprocal. Very good. It's the reciprocal function. But you're right. The negative will make it 3 over x to the 15th, which is a reciprocal function. Oh, there's Maggie.
Yeah.
Thanks. Mm-hmm. All right. What about B? Is that a polynomial or no?
Yeah.
No.
Wait, no.
Why not?
The
Good, because of the radical.
fifth root.
The fifth root. Mm-hmm. So it's a radical function. What about C? I'm going to count C. What kind of special function is it? What'd you say? It is a binomial, but like this x means what shape?
Oh, it's a parabola.
Linear.
It's linear.
Oh,
I will go double check and make sure I can count linear and quadratic as polynomial. I just know this chapter is called polynomial and we do linear and quadratic with it, so I'm counting them. If I am wrong, I will come and correct myself next class. What about letter D? Yes or no?
yes.
Yes. Max, what kind of graph is this?
That's
That is the parabola. That's my quadratic. And then what about the last one? Yep. I think that's a pretty classic polynomial function. It's a x to a very big number. We're not useless. We don't have a name for this kind of graph. This is just a polynomial function. Okay. We're doing a lot of review today. We're talking mostly about lines and about parabolas, quadratics. Some stuff might be a little bit new to you, but I'm gonna not rush, but like hurry ourselves through the stuff that we should know already, because I already did do lines with you guys. Hi, thank you. Okay, so this one where it says write the equation of a linear function given this information. Okay, I'm gonna go slowly through this because I feel like we always forget this. When I have in the notation, I'm in function notation right now. It says f of 2 equals 3. I can treat that x as my, or 2 as my x, and then 3 is your y. So this notation says that I have an ordered pair 2, 3. What would that make my other ordered pair here? 4, 11. Good. So again, my 4 is my x and my 11 is my y. So 4, 11. Now that I have 2 points, you guys can easily do x1, y1, x2, y2, and find slope and find either point slope form or slope intercept form and find the equation of this line, correct? Mm-hmm. Okay. Let's remind ourselves some formulas. So I'm going to write these right here. I'm going to say, okay, slope is m. Oh, are the x's or the y's on top? I always forget.
the X.
Why?
The y's are on top.
It's on the bottom.
The x's go on the bottom. Good. And that's, we often forget that, so I want to make sure we do that. Let's do. All right, slope intercept form. we'll say y equals mx plus b, and then point slope form is y minus y1 equals mx minus x1. Now, if you know those, you don't necessarily have to have those written. I just was assuming maybe we forgot them, so might as well write them and remember them. Gonna highlight them just so I can reference them again. And now I'm going to use those equations to find my slope-intercept form. So we will do 4 minus 3 over 4 minus 11 minus 3 over 4 minus 2. So 8 over 2 equals 4. And then I'm going to use the point 2, 3. That will be my x1, y1, so it'll be y minus 3 equals 4 times x minus 2. Distribute that through, x or y minus 3 equals 4x minus 8. Add 3 to both sides, y equals 4x minus 5. Okay. Anybody questions yet? Okay, can you do the next one on your own? Do letter B on your own. I'll put my work up on the board in a second.
If your phone got dug out, put that back away. So you guys, distinction, I want to make sure you guys do understand. I know I do. All I think we kind of missed was the name of science here, right? And let's talk about why it's a plus, why it's a minus, like what is the possible experience, right? This negative 5 is going to go in for y sub 1. So because it's y minus negative 5, that's like that one. I can see you guys just make it happen.
All right, I still have letter A on the board, but I also just did letter B, so I'm going to put that up on the board too. You can see both of them. So check your slope, make sure you got the same slope I did. Check your equation, make sure you got the same equation I did. You don't have to do your equation the same way I did. That's just what I chose to do. Cool, any questions? This is a nice little linear review, right? We like a little softball kind of questions in pre-cal. All right, the next one, we got another little softball before we do something a little bit harder. I want to talk to you guys about vertex form. Is that something that's familiar to you? If I say vertex form, I see some nodding of heads. I see some looking unsure. I'll pretend like you've never seen it before, just like I always do. What I have here is my standard or my general form of a quadratic looks something like this. We say y equals ax squared plus bx plus c, right? Whenever we do quadratic formula, we need to make sure it's in this form. You guys know what your a's and your b's and your c's are, right? This is familiar. Vertex form is just another way to write this. It's y equals a times x minus h squared plus k. And I'll highlight this in yellow again, kind of have my formulas as like a little reference back. What'd you say?
I remember doing this.
Yeah, okay. So maybe it wasn't at top of mind, but now you're like, okay, it's getting dug out of the depths of my brain a little bit. That being said, Ava, if you remember this, do you know what my vertex in this equation is? What letters reference my vertex? The H and the, okay, good. Is the H negative or positive?
The H is would be
It would be right, what do you think? Negative? Zach, what do you think?
-1, -4.
Oh, no, so I'm not there yet. I'm gonna ask that question in a second. Just here, I'm looking at my H and my K. I want the H to change signs of what it was. So if it was negative in here, then I want it to be positive. Remember like when we were doing transformations and I told you everything inside the parentheses is opposite of what you want it to do? So if it says minus H here, I want it to be minus, but it's opposite of what I want. It has to be plus. Now, does the word axis of symmetry mean anything to anybody? Andrew, ooh, you popped right up. Tell me about
It's
axis
like
of symmetry.
The dashed line that's like in between the parabola
Okay,
and
you know what it's in reference to?
it displays obviously like the symmetry between
Okay.
the two.
Yeah.
So like it shows the negatives on one side and the positives on the other.
Good, it's my line of symmetry. So like quadratics are symmetric, and when they're not around the axis, so I drew this one purposefully off the axis because normally we're like, oh, the y-axis just splits it right down the middle. If it's not on the y-axis, it's split down the middle somewhere else, and it's directly in the middle. Do you remember what is my axis of symmetry? Like what would that be in terms of like numbers or what I see here,
It's
Sophia?
the x value of the vertex.
It's the x value of the vertex. So the x value of the vertex is my axis of symmetry, and I abbreviate that as AOS. So in this case, that would be what letter? No, sorry, I'm not on my problem yet. What would that be here? What would my AOS, what's my x value of the vertex? Andrew? H, very good. And then the last thing I'm going to ask you is about direction. The direction of the graph will either go up or down. Where do I look to know if it goes up or down? Jane, what do you say? A, good, we look at A. And whatever A is, that's what it is. So if it's positive, we go up, and if it's negative, we go down. Okay, so now that we kind of talked very hypothetically about it, let's go look at those 3 examples, and I want you to tell me what all of these pieces mean. Maybe I should label this guy as the vertex. Okay. So on this first one, Zach, you had the vertex a minute ago. What is the vertex?
-1 and -4.
Good. -1, -4. I like that you switched the sign for the 1. You kept the sign for the 4. Very good. All right, what's my axis of symmetry? Anybody? Quinn? -1, good. I like to write x equals -1 because x equals is a vertical line. So as your resident math teacher, I have to give you the best form. If you just write -1, that's fine. I just need you to know it's a vertical line. And then does this go up or down?
Down.
Why?
Because the 3 out front is negative.
Good, because the negative out front. Good. Can you do the next 2 really quick on your own? Identify the following. All right, take 1 minute. All right, first one, who knows my vertex? Ava, tell me vertex.
3, 0.
3, 0, good. Somebody else tell me axis of symmetry. Ryan. 3, good. X equals 3. Somebody else tell me up or down.
Up.
Jack. Up. Very good. Let's wait for a hand. Max, is that you? You want to do the next one?
Sure. The vertex is -3.
Good. Somebody else. What's my axis of symmetry? Andrew? X is equal to -3, and then last up or down. Maggie? Up. Very good. That was pretty easy, right? Awesome. Okay. It's really easy to find those 3 things when it's written in vertex form. However, as you turn the page, you're probably like, oh man, now she's not going to put it in vertex form when we have to do this. You guessed it correctly. Now I have it in general and a standard notation, and we want to rewrite it into vertex form. Now, to put it into vertex form, we have to use an old skill. We have to use our completing the square knowledge. Do you remember completing the square back in Unit P? Yeah, I know, it's been a little bit. So we're gonna walk through this one, and then we'll try the next two. We'll probably walk through the first two mostly together, and then I'll have you try the last one. So sometimes we see this f of x and we get all panicky. You can remember f of x is the same thing as y, but actually I'm not even gonna mess with it for a little bit because I'm gonna start by moving my 3 to the other side. I'm gonna add 3 to the other side so I can only get x's on one side. I'm gonna get all my constants on the other side. So I've got 2x squared plus 4x plus blank. Oh, sorry, thank you. Negative 2x squared plus 4x plus blank equals 3 plus a blank. Remember, we're really dramatic. We put those little blanks there because we're going to fill something in a second. Now, most of the completing the square we did last time did not have any coefficients, but I believe that we're advanced enough. I think we can practice now with some coefficients. Remember that in order to move on from this, we have to factor a -2 out of everything on the left side. The right side, that 3 plus the blank does not change, but the left side, I have to factor -2 out of all of my terms. Bless you. -2x squared divided by -2 is just x squared. 4x divided by -2 is -2x. And then I still have my plus a blank, just kind of waiting there. Now, who remembers, why am I dramatic? Why is there a little blank there? What am I waiting for? What am I saving a spot for? Zach?
So you have to complete the, take the b minus b divided by 2a.
Then we're going to do b divided by 2a. So whatever b is, just take b divided by 2. Oh, no, wait.
Negative b.
No. You're thinking of the next step. But we are doing a b here. We're going to do b divided by 2 squared. I want you to, I'm going to ask you that in like 40 minutes after lunch, because that is what we're doing next. We're going to do regular b divided by 2 squared. That is going to fill in what I'm completing my square with. Okay? So in this case, what's my b? No. It's the -2. It's my new b now that I've moved on. That's why I wanted to ask. We have to do what we currently are looking at. So I'm going to do -2 divided by 2 squared. So that becomes -4. Nope, -1. I don't know what I was doing there. Sorry. -1 squared is 1. I'm going to add 1 in the first blank. Am I going to put 1 in the other blank, or am I going to put something else in the other blank? Brian?
Isn't it like the whatever the parentheses, so it'll be like 2 times 1.
We have to think of it. We're not just adding 1 to both sides. We're doing -2 times 1. So I'm going to add -2 to the other side. Okay, now I'm going to start simplifying. So I've got -2, and I've got x plus or minus a number squared equals 1. What number goes in this blank? Not -2. -1. Why -1? Opposite sign of what? Yes, that only works because there's a 1 here, but if it was like 16, yeah, Megan?
Isn't it just whatever your b divided by 2 is?
Yes, that was another trick I taught you. So whatever your b divided by 2 is, goes in the same spot. I'm going to use a different color to kind of prove that point. This number goes here always. If not, if you can't remember that little trick, think about, okay, what number squares to be +1, but then adds to be -2? That's why it has to be a -1 this time. Okay, I'm just in my final step. In order to we're not actually completing the square, we're just using complete the square in order to get to vertex form. My last step is I'm going to move the 1, or I'm going to move whatever the constant is on the right back to the left. So I'm going to have -2 x minus 1 squared minus 1. And I can set that equal to y again, or I could use my function notation f of x. So -2 times x minus 1 squared minus 1. Now I'm in the right form that we started with, right? What's my vertex? Good, +1, -1. What's my axis of symmetry? 1. Am I going up or down? Down. Let's look at the next one. We're just gonna be able to start this. Does anyone have any questions before I start looking at another example? Interim, yes or no?
Oh, can you complete the square by like dividing the two now, or is that just like more complex?
Ooh, I don't want to make any definitive statements because see how like we never affected the 3 with the when we divided the 2, we only dealt with those 2 numbers. I'd have to do it and see if it matches this. Or like you can do it on your own. You can divide everything by -2 and see if you get the same thing as what we get. But I don't want to make any yes you can definitive statements on that today. Yeah, Max.
What does it say under vertex?
It says AOS, axis of symmetry. Alright, the one thing I want to do before we go to lunch to set this problem up so it's easier when we come back is just do my initial step by moving my 1 to the other side. So I'm going to have 1/2 x squared minus 6x plus blank equals -1 plus blank. And then I want to factor this 1/2 out. Now, I don't know about you, but sometimes fractions are a little funny in my head. Like I think I'm good, and then I have to factor 1/2 out of -6, and I'm like, I have no idea what that is. We know factoring 1/2 out of 1/2 x squared just leaves us x squared, right? We're good with the first one. Now, for me, I think the best way of thinking about how to factor 1/2 out of 6 is to ask myself, okay, if I was going to like essentially go backwards, if I was going to do 1/2 times this number and get -6x, what number would have to be here? 1/2 times what number would give me -6x? Yes, Brian? -12x.
All right, guys, time to lunch. Back to 45.
Is everybody okay with how I did that? Good. So I have a hard time going the front way, but I can go backwards. I can say what number times 1/2 gives me -6. And I'm just going to set myself up with this plus blank. And that is a good stopping point. We'll go to lunch and we'll finish this when we come back. Okay. Be back at 45, please.
Wait, can I solve by doing -b over 2a? And
We're
then-
about to do that. If you look down on your notes, we're about to do that.
Oh, okay.
So you're just one step ahead of me.
Okay.